Alright, these notes are going to be on page 30, and the title should be Magnitude and Direction. So remember to give your page a number and a title, magnitude and direction. So magnitude is going to tell us about the length of our vector. And in order to find the magnitude for a complex number, let's use the example 4 plus 3i, which we graphed on page 29. So if we are looking at this vector to 4 plus 3i, if we want to find the length of that line, we're going to draw in a right triangle. And notice that the base of that triangle is the real part of our imaginary number, so it is 4 long, and the height of this triangle is the same as the height of our imaginary number, so it is 3 long. And since we have this right triangle, we can use a squared plus b squared equals c squared to find the length of c. So let's do that over here. And I'll try to get both of those in the picture so we can see both of them. So use a squared plus b squared equals c squared. So for example, our a is 4, so we want 4 squared. Our b is 3 plus 3 squared, and that will equal c squared. Anytime when you're working with the Pythagorean theorem, you should always keep everything on the same side of the equation as you work down. So we're going to work down the page. 4 squared is 16, plus 3 squared is 9, and that's going to equal c squared. 16 plus 9 is 25, so 25 equals c squared. And in order to find what c is, the length of that line, we need to take the square root of both sides. The square root of 25 is 5. So the magnitude of 4 plus 3i is 5. We're going to do a second example, and this time we're going to use -3 plus 2i, which you also have graphed. So that's this vector going to the left here, and we're going to go ahead and drop in our vertical line, and that line always goes from the point to the x-axis. So no matter where you are on the graph, you're always going to draw your vertical line to the x-axis. So again, A is our real part of our complex number, and B is the imaginary part of our complex number, and we are looking for the hypotenuse, or C. So in this example, we're going to have -3 squared. Notice that when it's negative, we have to put it in parentheses, plus 2 squared equals c squared. -3 squared is 9. 2 squared is 4. 9 plus 4 is 13. 13 equals c squared. Remember, to find c, we have to square root both sides. We cannot simplify square root of 13. So our final answer is the length of -3 plus 2i, the magnitude, is square root 13. And that's as much as you can do. You can't do any more. Okay. Oops, direct. So, talking about direction, we always measure direction from the x-axis, which is 0 degrees, so from the positive x-axis, moving counterclockwise to our vector. So it measures the angle from 0 degrees 2 vector counterclockwise. So for example, if we're looking at 4 plus 3i, we're going to start at 0 degrees and measure up to our vector 4 plus 3i. So that is our theta, that's the angle we are looking for. Remembering our trig functions, if this is the angle we're looking for, then we can use, we know b is 4, and we know a is 3. We can use tangent, opposite over adjacent. So the inverse tangent, and it will always be the imaginary number over the real number to find the angle that we're looking for. So in this example, we are going to look at 4 plus 3i. The imaginary number is, so we want the inverse tangent of 3 over 4. And when we put that into our calculator, it's going to tell us we're going to round it. It's 36.8, but we are going to round that to 37 degrees. So in this situation, as we're looking over here, we measured from 0 up to our vector, and that was the angle we were looking for. So we don't have to add to 180 or subtract from 360. We've directly found the angle we were looking for. But let's go to this example, negative 3 plus 2i. If we are going to measure the opposite over adjacent, we'll actually be finding this angle here. So let's call that angle alpha. And we'll do example 2. Negative 3 plus 2i. And remember, we need to draw ourselves a thought bubble here. When we are talking about lengths, lengths are always positive. So actually, when we were up here thinking about this problem, we didn't have to put in that negative 3 because we were talking about the length of this line. So that actually would have been a positive 3 because it's a length, and we don't measure negative lengths. All right, so we end up with the inverse tangent, our imaginary number over our real number. And we're going to use that as a positive 3, and we're going to go ahead and put that into our calculator. And it's going to tell us that that is 37 degrees. However, 37 degrees measured this angle right here. But that is not the angle that we want. We said direction had to be measured from the x-axis, or from 0 degrees, to our vector. So in this instance, if we went all the way over to this negative part of our real line, then we would have gone 180 degrees. But we didn't go all the way, we stopped right here. So we have to subtract this angle that we found from 180 in order to find the angle that we are actually looking for. Ooh. This was a mistake. It was 33.6, which would round to 34 degrees. We're going to go ahead and fix that. And we're going to do 180 minus 34, and that tells us that that angle is 146 degrees. 146 degrees. All right, on our graphing page, let's go ahead and make ourselves another small coordinate plane and label our real and imaginary axis. And so if we are in quadrant 1, we know that both our imaginary and our real numbers are positive. And so we're just going to use the inverse tangent of the imaginary over the real number without subtracting or adding. If we are over here in quadrant 2, we know our real number is negative and our imaginary number is positive. And when we are in this quadrant, we have to subtract from 180 to find our direction. If we come down into quadrant 3, so I'm going to go ahead and draw in some example vectors here. Okay, in quadrant 3, we've gone all the way to 180 plus a little bit. So in order to find that direction, we have to do 180 plus our inverse tangent. And in our last quadrant, if we have a vector that's here, our inverse tangent will find us this angle, but that's not what we want. We want to go all the way from 0 all the way around to that vector. If we'd gone all the way back to 0, we would have gone 360, but we didn't. We didn't quite make it, so we have to subtract from 360. So that gives you an example, and let's go ahead and label in quadrant 3, we would have a negative real number and a negative imaginary number. And in quadrant 4, we would have a positive real number and a negative imaginary number. So that kind of gives you a guideline of